Alright guys, welcome back. And this is the second video that will kind of take you through this M&M Discovery Lab. This is going to focus on graphing calculator stuff and how to use the graphing calculator to help you out. So, what we need to do today, as you notice, you've got your M&M Discovery Lab. You should be done at the first page. So second page, here's what it wants us to do. It says find a linear regression equation, a quadratic regression equation, and an exponential regression equation to fit the data using the regression feature on your calculator. Round to the nearest hundredth. So, what you need to keep in mind, what we're basically looking to do here, we're comparing three different types of functions. We're comparing linear, quadratic, and exponential. What regression is talking about, so where you see this word regression, that's looking for what's called a line of best fit, which you might have seen before in some other classes. You might have seen this in science classes, especially like to use it. But basically, we're going to use three different models. What we're going to try to find out is, does a linear equation work best? Or maybe does quadratic work best? Or does an exponential model work best for this scenario we just got done working with? Okay, so in order to do so, we first need to put all of our data in. So on a graphing calculator, here's what you need to do. You need to, from your home screen, go to Stat. There's a button right here for Stat. And we want to edit our statistics. So we're going to click on Edit. What that will do, it'll open up this kind of menu where there's a whole bunch of lists. In list 1, put in all of your trial numbers. And again, remember, do not include the last one. So for me, that means I only got up to 5. So I type in 0, press enter, 1, enter, 2, enter, 3, 4, and 5. So the second column is going to be the number of M&Ms. So in that second column, once you go over to that one, you just type in 15, then type in 8, then 6, then 3, then 1, and remember we're not including where it was 0. Now, let's just talk about graphing. So let's for right now just work on graphing all of this data. So what I want you to do, in order to graph stats, what you have to hit second y equals. Notice how it says stat plot above there. Now, for plot 1, what you need to make sure you do, make sure plot 1 is turned on, and then for type, you want to choose a scatter plot. So this option, the very first option, is scatter plot. Now your X list, that's your first list that we would have used. So that's list 1. So notice for mine, it just went to list 3. If yours is on something other than list 1, like mine is, hit second 1 for list 1. If you notice, list 1 is right here. For Y list, that's where you choose list 2. So now that's where you make sure it's list 2. If it's not, just hit second 2 for list 2. If you want list 3, hit second 3, 4, second 4, second 5, second 6, depending on what list you want. Now, for the window, let's get it to look somewhat like what ours did. And if you go back to what your graph did, ours went from an x value of 0 to 10. So let's make ours in a similar way. So what you'll do, go to your window. For x minimum, let's make that 0. And let's make our x maximum 10. Now for the x scale, we counted by ones. So for x SCL, the x scale, we counted by ones. Let's change that to be a 1. And then for the y's, let's see. For my y values, we went from 0 up to 20, and we're counting by 2s. So for me, my y minimum would be 0. My y maximum would be 20. And then for my y scale, there I was counting by 2s. Now, the rest of this, the x-res, the delta x, and trace step, you don't need to worry about. What you should be able to do now, and yours might be different, so go by whatever you had. If your y values went from 0 to 10 and counted by 1s, just leave it like that. But let's go ahead and hit graph and see what it looks like. All right, very cool. So if you compare the two, here's what this one looks like, and here's what my graph looked like. And they look, to me, almost the exact same. It's kind of cool. All right, so now let's talk about those actual equations, because remember what we are looking for. We're looking for a linear, quadratic, and exponential regression equation. So let's start with linear regression. To get to linear regression on your graphing calculator, go to Stat, over to Calc, And then if we want linear regression, look for something that says something like linear regression, which, hey, there it is. Guys, what you're going to start to find, you're in Honors Algebra 2. The more you know your graphing calculator, the better off you're going to be in every math class you take from now on. Meaning instead of playing games on your MacBook while we're taking notes, maybe have your graphing calculator out and start playing around with it to where you can find stuff more quickly. Okay, so for linear regression, what I'm going to do is kind of like what we did when we were typing it into our graph. So make sure X list is list 1, Y list is list 2. And for right now, let's go ahead and skip the frequency list and storing the regression equation and go ahead and hit calculate. Now, here's what mine gives to me. It tells me A is negative 2.68, B is 12.38. Both of which, if you notice, you substitute into this equation up here, gives you the formula for a line. Now the other thing it wants is this r squared value, which mine did not give to me right away. So what you need to do, if yours is the same as mine and is not giving you an r or an r squared value, you need to, on your graphing calculator, go to Mode, and then go down to somewhere where there's an option that says Stat Diagnostics. And yours might look a little different than mine. Should have that option somewhere though. So look for Stat Diagnostics and turn that to be on. Now, once you've done that, we're going to do the same test we just did. So we're going to go back to Stat, over to Calc, and then again do that linear regression. This time, and again it should all be ready to go, go ahead and hit calculate. What you'll notice, it still gives you A, still gives you the same B, but now it gives you this r squared value that you're looking for. Okay, so our equation, y equals, in this case, negative 2x, or let's see, negative 2 point, and what's the nearest hundredth, negative 2.69x plus 12.38. Okay, and then it also is going to want our r squared value, which is 0.88. Go to the nearest hundredth there. Okay, so just to write down what my linear regression equation is, here's what we found, the line of best fit. If you were to graph the line, y equals negative 2.69 multiplied by x plus 12.38. And we said the r squared value for this one was a 0.88. All right, now let's do the same thing, but let's do quadratic regression. So basically what you're going to do is the same thing. Go to Stat, over to Calc, and now that we want a quadratic regression, look for something that'll say quadratic regression. And then do the exact same thing. X list is list 1, Y list is list 2, and then we're going to hit calculate. All right, so for this one, notice that it's in the form of a quadratic equation, which is what you should expect. And it's telling you A is 0.625, B is negative 5.81, C is 14.46. So that's going to be what you use, put it into your equation for your coefficient. So for mine, 0.63x squared minus 5.81x plus 14.46, and it's telling me my r squared value is 0.98 to the nearest hundredth. Okay, so to write that down, my quadratic regression equation, here that is, we're going to say that y is equal to 0.63x squared, and yours will probably be different than mine, that's okay, minus 5.81x plus 14.46. Now, the reason yours is most likely different is most likely you don't have the exact same values. So you wouldn't have all of these values right here on your graph because your trial number and number of M&Ms are different. So just know yours is going to be different unless you somehow rolled the exact same thing I did, which honestly I highly doubt that you rolled the exact same thing I did. Nice try. Now, r squared value for this one was a little different. It was 0.98, and we'll talk about what that r squared value means. Okay, last one we're going to do is exponential regression. So let's go back to graphing calculator, once again to Stat, over to Calc, and let's look for exponential regression. So let's see, quartic, cubic, Another linear ln xp, there we go, exp regression. Once again, list 1, list 2. Let's go down to calculate and see what it gives to us this time. Okay, so for this one, it's telling you, and this is in the form of an exponential equation. Notice it says y equals a multiplied by b to the power of x. So for mine is going to be y is equal to 15.52 multiplied by b, so 0.56 to the power of x. And the r squared value for this one, 0.96 if you round to 2 decimal places. Okay, so my exponential equation, here's what I'm going to write down, and yours might be a little bit different, a little bit the same, is going to be this. Y is equal to, we said 15.52 multiplied by, and because we're multiplying, I'm going to put this in parentheses, especially with decimals, multiplied by 0.56 to the power of x. And my r squared value for this one was 0.96. Now, what r squared values basically tell you is how good your regression equation is. The closer your r squared value is to 1, the better the fit. So, in terms of looking at r squared values, because number 5 asks which equation models the data best, the r squared value closest to 1 is 0.98 for quadratic. Now, that may be. Here's the problem with quadratic. If it is going to be quadratic, then what our data should do, if it is going to look, and it does look like half of a parabola here, if you were to kind of sketch in a graph, it does look like it could be a quadratic. But a quadratic has to have 2 sides. It needs to be going back up. And here's the deal. Based on our experiment, would we ever have the number of M&Ms start going back up? The answer there is no. In other words, quadratic is not going to be a very good fit. So just because it says the r squared value is the best fit for this one, you have to think about it in the real world mindset. Your equation, your graph is not going to all of a sudden turn and go back up. So instead, what we're going to say for which equation models the data best, we are going to go with an exponential. We're going to say that our exponential equation works best, even though the r squared value is a little bit less than quadratic. And the reason being, again, quadratic would have to go back up. Exponential just keeps going down. Now, the next thing, it's going to ask you, does your graph show exponential growth or decay? And let's take a look. The graph we made showed that it looked like as our number of trials went on that we were going down. And if we were to again draw in kind of a curve here, you can see that we're going down, which means it's not growing. It means that you've got exponential decay. Now, how can you tell by looking at the graph? All you'd have to say there is that the y values are decreasing. Now, we haven't talked so much about this, but there is also a way that you can tell this by looking at the equation. So looking at the equation, I want you to check to see if you can find a way that you can tell. So looking at just this y equals 15.52 multiplied by 0.56 to the power of x, is there a way looking at that equation you could tell that it's decay? What do you think? Is there a number there that would help you out? All right, I'm going to give you some hints here. So if you want to keep thinking about it on your own, go ahead and pause the video. Remember that when we were talking about exponential equations, and this goes back to what we were talking about last unit, we said that this number in parentheses, we called it a couple things. We called it the base. We also called it the multiplier. In other words, the reason we call it a multiplier, that's what number you'd be multiplying by each time. Now, we said the number in front was your initial value. It was what you started with, which, hey, now some stuff is starting to come together because initial value is close, 15.52 is really close to the number of M&Ms we started with. It's really, really close to 15. Now the multiplier, the base, if you think about rolling M&Ms, there was kind of a 50-50 chance that you were going to get an M or not get an M. So now the multiplier should start to make sense too. It's pretty close to 50-50, 0.56, pretty close to 0.50. Now, when we talk about multipliers, one number in the world that when you multiply by it does not change anything. And that one number is the number 1, which means multiplying by 1 doesn't change anything, which then would have to mean that multiplying by anything less than 1 would have to be where you are going down. That's going to be how you can tell by looking at the equation. Is we're going to say that because 0.56 is less than 1, this is going to be what tells us that it's decay. If it was greater than 1, that would be what would tell you that it's growth by looking at the equation. Alright guys, that is the conclusion of the second video. In the third video, we will then go through these last 2 questions, and then you should be done and ready for class on Monday. Or on Wednesday, Wednesday. 4-day weekend, enjoy it. Alright guys, next video is coming up soon. Please go ahead and click on that if you're ready for it. Otherwise, go back and work through anything else that you need to. Alright, see you next time.